Hey everyone, and welcome back for another deep dive. You folks really love science, and especially when it intersects with religion and spirituality, so that's where we're headed today.
Well, I think it's fascinating that the Star Talk episode was sent in.
Oh yeah,
Yeah. Neil deGrasse Tyson and D. Chuck Nice answering viewer questions.
they're a great pair.
I know, right?
Yeah,
It's like, what a combo.
I know. And they're not just any old questions either.
No.
Like we're talking wormholes, artificial intelligence, the soul, and even like what nothingness really means.
Oh, wow.
I feel like we're about to go down a serious rabbit hole here.
Let's jump right in. One viewer from Minnesota wanted to know if wormholes do exist, what would they look like?
Oh yeah.
Yeah,
It's a question that, it really captures the imagination.
it does.
I mean, when I picture a wormhole,
Yeah.
I kind of imagine like a tunnel,
Right.
with an opening at either end.
That's kind of a misconception.
Okay.
Yeah, it makes
Yeah.
sense, like, based on our everyday experience with holes. But the nature of a three-dimensional wormhole is so much more complex.
Oh.
It wouldn't have, like, a clear opening in the way we imagine.
So like no swirling vortex of light.
Not quite.
Okay.
Modern physics suggests that a wormhole would probably appear the same from any direction you approach it.
Oh, interesting.
It'd be more like a spherical distortion in space-time.
Oh, okay.
And, it's interesting, though, how pop culture tries to represent this,
Yeah.
even if it takes liberties like Doctor Strange or Rick and Morty.
Yeah.
They offer up these really visually cool, but ultimately fictional visuals.
Right. Even in fantasy, we try to ground things visually. Yeah.
Absolutely. And speaking of grounding things, what's really interesting is how Neil deGrasse Tyson actually used wormholes to explain how Superman could have traveled to Earth as a baby, faster than the speed of light.
Wait, what? Really?
Yeah.
He's saying that Superman traveled through a wormhole.
Exactly. Apparently, he even consulted on an issue of Action Comics to explain how that journey could have been possible.
Oh, wow.
The light from Krypton's explosion would have taken years to reach Earth, but Superman arrived shortly after his birth.
Right.
And the only way that that could happen is through a wormhole.
So you're saying Neil deGrasse Tyson is officially part of the Superman canon.
Yes,
That's a fun fact.
it really is. And it kind of speaks to this larger point that our understanding of the universe is constantly evolving, and even like these seemingly impossible feats can sometimes be explained with real science.
It makes me think about this one question that a viewer asked Tyson, whether he'd ever had a religious experience while observing the universe.
That's a really loaded question, isn't it?
Yeah, it is.
And Tyson's answer was really nuanced. He acknowledged feeling this deep sense of awe and connection to the cosmos, but he stopped short of calling it a religious experience based on how others describe those experiences.
Do you think that his scientific knowledge prevents him from having those kinds of unexplained experiences that might lead other people to religious interpretations?
That's a really interesting question, and it's something that Tyson hints at himself.
Yeah.
He seems to suggest that his understanding of physics often provides him with rational explanations for things that might otherwise seem, supernatural. It's
Right.
like he's wired to seek out a scientific basis for what he observes.
So instead of being on his knees and wondering what
Right.
mystical force,
Exactly.
it's like, oh, okay, this is the physics at play here.
Right.
Yeah, that's fascinating.
It really is, and it leads to another question that Tyson himself raises. Could we actually design a scientific experiment to prove whether or not the soul leaves the body upon death?
Whoa. Okay. How would you even begin to test something like that?
So Tyson proposes this really simple but elegant experiment.
Okay.
Imagine a message written on a ledge above a dying patient's bed.
Okay.
Something straightforward, like the sky is blue. If people who have near-death experiences can actually see their body from above, as they often claim, they should be able to read the message and report back on it later.
It's like a scientific control to verify those anecdotal accounts of out-of-body experiences.
Exactly.
Makes you wonder what we could discover if we applied more scientific rigor to these types of questions.
Right. And, it's not a new idea either. Like when X-rays were first discovered, people actually tried to capture the soul leaving the body on film.
Really?
They thought it might have some kind of electromagnetic signature.
Oh, wow.
It shows how human curiosity has always sought to understand the afterlife using whatever tools are available.
Speaking of pushing the boundaries of understanding, another viewer asked whether it's even possible to achieve absolute nothingness
Right.
by getting rid of every single atom, like every particle.
Right.
It's a concept that's so hard to wrap your head around.
It is, and Tyson explains that even if you could create this perfect vacuum where there's supposedly no atoms or particles,
Yeah.
quantum physics suggests that there would still be something there.
You mean like those virtual particles that we hear about?
Yes. Think of them as tiny bits of energy that kind of pop in and out of existence.
Ah.
Even in a vacuum, they're constantly fluctuating, appearing and disappearing, even where there's supposedly nothing.
So even in a vacuum, the universe is buzzing with activity.
Exactly.
Wow.
And here's where it gets really wild. These virtual particles are thought to be entangled, meaning they're connected in some way.
Yeah.
And recent research suggests that these connections might actually occur through mini wormholes.
Wait, mini wormholes.
Tiny.
Everywhere.
Potentially, yes.
Oh, wow.
And some physicists, like Brian Greene, believe that these mini wormholes connecting these entangled particles might actually be the fabric of space-time itself.
Okay, my mind is officially blown.
Right.
So if you were to somehow eliminate all particles, even virtual ones, would that space truly be empty if the laws of physics, which depend on space-time, still applied?
That is the mind-blowing thought experiment that Tyson and Greene were exploring.
Oh.
It's like the concept of empty space becomes meaningless because the space itself arises from these interconnected particles and these mini wormholes that weave them together.
I think we need to pause here for a second.
Yeah.
We've gone from Superman traveling through a wormhole to the possibility that true emptiness might not even exist.
Right.
This is a lot.
It's a lot to process, but this is what makes these deep dives so rewarding, right? It's about challenging our assumptions and expanding our understanding of the universe.
Absolutely. And this is just the beginning. Up next, we'll explore whether artificial intelligence has the potential to make major scientific discoveries and Tyson's advice for fostering a love of science in a child, which might surprise you.
It's amazing to think about this idea of interconnectedness, right? Like at the quantum level, it's like the universe is constantly weaving together space-time, matter, and energy in ways that we're only beginning to grasp.
It really makes you wonder, like, what other mysteries are out there just waiting to be uncovered?
Oh, totally.
And speaking of mysteries, let's shift gears a little bit and talk about artificial intelligence. Okay. A viewer asked if AI will be able to make major scientific discoveries in the near future. What are your thoughts on that?
Well, it's a question that sparks a lot of debate.
Yeah.
Tyson's response was interesting. He's cautiously optimistic.
Okay.
He acknowledges the incredible power of AI when it comes to data analysis.
Right.
But he also questions whether it can truly replicate that human spark of creativity and intuition that leads to those groundbreaking discoveries.
So AI can, crunch the numbers
Yes.
and find patterns, but can it actually, think like a scientist?
That's the key question.
Yeah.
Tyson argues that, at least for now, AI lacks that kind of real-world experience and the ability to make those unexpected connections that often drive scientific breakthroughs.
Right.
He uses this really interesting example involving Chuck Nice discovering a new species of mollusk.
Okay, I'm intrigued. Tell me more.
So imagine Chuck is on vacation in the Bahamas,
Okay.
and he stumbles across this unique seashell.
Yeah.
He sends a handwritten letter to this colleague who specializes in mollusks.
Okay.
Boom, a whole new species is added to the scientific record.
Right.
But here's the catch. If Chuck's brain was uploaded to the internet
Okay.
and powered by AI,
Yeah.
that discovery wouldn't have happened.
Why not? I mean, wouldn't AI be able to identify a new species based on its physical characteristics?
Well, it might if it had access to that data.
Right.
But in this case, the discovery hinged on Chuck's real-world experience, his personal connection with his colleague, maybe even a little bit of serendipity.
Oh.
AI, as it exists now, couldn't replicate that chain of events.
So it's not just about processing information.
Right.
It's about those chance encounters, that human element of curiosity and exploration
Yes.
that AI can't quite replicate, at least not yet.
Exactly. Which brings us to another really fascinating question from a listener. They wanted to know how to foster a love of science in their young child, in the age of social media and constant digital distractions.
Totally. I mean, kids today are bombarded with information and entertainment. It's hard to know how to, encourage that natural curiosity without overwhelming them.
And Tyson's advice on this is surprisingly simple. Get out of their way.
Really. Just let them run wild and explore.
Well, maybe not completely wild,
Okay.
but he makes a really powerful point
Yeah.
about how children are natural-born scientists.
Uh-huh.
They're curious, they love to experiment, they're not afraid to get messy.
Which can be a challenge for parents who value tidiness.
Oh, definitely.
Yeah.
But Tyson argues that we often stifle that natural curiosity by trying to keep things too neat and orderly.
Okay.
He encourages parents to embrace the mess and see their homes as, like, laboratories for their children to explore.
So instead of stopping a child from, like, breaking an egg to see what's inside, you encourage them to crack it open.
Exactly. It's about letting them learn through hands-on experience,
Yeah.
even if it means a little bit of mess.
Right.
And it's about resisting that urge to over-explain everything.
Yeah.
You know, let them figure things out for themselves, ask their own questions, come to their own conclusions.
I think there's a balance, though, right? We can't just let kids, like, do whatever they want, especially if it's dangerous.
Absolutely. Safety is always paramount.
Right.
But Tyson's point is that we often underestimate children's capacity for learning and discovery.
Yeah.
And we might be inadvertently squashing their natural curiosity by being overly cautious or controlling.
Yeah.
He wants parents to see their children as capable explorers and encourage that sense of wonder.
I love that. It reminds me of that saying, every child is an artist. The problem is how to remain an artist once we grow up.
Right.
Maybe it's the same with science.
Just a great analogy.
Yeah.
And Tyson argues that it's not just about encouraging exploration.
Yeah.
It's also about embracing failure.
What do you mean by that?
So he tells this story about Icarus,
Oh, yeah.
who famously flew too close to the sun and melted his wax wings.
Right.
Now, we might look back and laugh at Icarus's mistake.
Yeah.
But Tyson points out that Icarus actually taught us a valuable lesson. Don't make wings out of wax.
So every experiment, whether it's a success or a failure, teaches us something.
Exactly.
Yeah.
It's about shifting our perspective and seeing failure as like a stepping stone to discovery.
I like that.
And that's something we can apply to all areas of life, not just science.
It makes me think about how Tyson describes the difference between a child who gets a shock from connecting two wires and says, I'll never do that again,
Yeah.
and a child who says, I wonder if that happens every time.
Yes. That second child
Yeah.
embodies that scientific spirit. They're not deterred by the setback. They're intrigued by it.
Totally.
They want to understand why it happened
Yeah.
and if it will happen again.
And that's that spark of scientific inquiry, isn't it?
It is.
It's something that, like, we can all nurture within ourselves, regardless of age.
Absolutely. It's about approaching the world with that sense of wonder, asking questions, experimenting, embracing the unknown.
Yeah.
It's about remembering that the journey of discovery is just as important as the destination.
Totally.
And speaking of journeys,
Yeah.
we've covered a lot of ground in this deep dive.
We've explored wormholes, pondered the meaning of nothingness,
Right.
and even delved into the mind of a child.
And through it all, we've been guided by the insights of Neil deGrasse Tyson, whose passion for science and infectious enthusiasm just shine through in every answer he gives.
He's a true inspiration, reminding us that the universe is this vast and endlessly fascinating place full of wonders waiting to be uncovered.
Right.
Wow, it has been quite a ride.
Yeah.
From the vastness of space and the mysteries of the soul to the everyday curiosity of a child.
I know, right?
Makes you realize there's just so much out there to discover.
There is, and it kind of brings us to a final thought-provoking question for all of you.
Yeah.
Think about those things that you encounter every single day,
Uh-huh.
like the things that you might take for granted.
Right.
What seemingly mundane phenomena in
Yeah.
your life
Yeah.
might hold deeper scientific significance if you were to investigate them with the curiosity of a child.
It's such a great question. We often, we lose that sense of wonder as we get older,
Yeah,
but if we can tap back into it, who knows what we might find?
totally. Maybe it's the way your coffee swirls in your mug.
Oh, yeah.
Have you ever thought about the physics of fluid dynamics at play there?
Or maybe it's something even simpler, like the pattern of cracks in a sidewalk.
Ooh, yeah.
What can those cracks tell us about, like, the stresses and strains
Right.
on urban infrastructure?
Or how about the way your dog tilts its head when you speak?
Oh, yeah.
Could that unlock new insights into animal cognition?
See, the possibilities are kind of endless.
They are.
It's all about just paying attention, asking questions, and never losing that sense of awe and curiosity
Right.
that makes us human.
And remember, you don't need a fancy lab.
No.
or a degree in astrophysics
Yeah.
to be a scientist.
The world is your laboratory.
Exactly.
So go out there, observe, experiment, never stop learning. Who knows what you might discover?
Well, that brings us to the end of this deep dive.
It does.
It's been a pleasure exploring these fascinating topics with you.
I agree. I always learn so much from these conversations, and I hope you did too.
You know, we covered everything
That's
from
fun.
the mind-bending nature of wormholes
Yeah.
to the profound implications of quantum physics.
Right.
And we even touched on the importance of nurturing a child's natural curiosity.
It was all inspired by your interest in science and those big questions about our place in the universe.
Absolutely. And remember, the quest for knowledge is an ongoing journey.
It is.
Keep exploring, keep asking questions, and keep that spark of curiosity alive.
Until next time, keep looking up.